boundaries nailed down. We're going to talk more about this with your domain models. But generally, during an exception phase, you would probably just sort of get an idea of what is it we're going to design here. They may already have a database system in place that you'll have to interface to. Or maybe they don't have one and you'll have to install one. And you'll have to make some decisions. Is that going to be online? Do you host it up on a web server someplace? Or is it going to be in a server in their building? Okay? How's that going to be handled? You basically would sort of draw this, be a little bit of a kind of a domain picture to start with, but this is the general sketch just to get the feel for what the overall picture is. Note the system boundary. We do not include the hosting systems. They're not part of what we're building. We'll see more about this when we get into domain modeling. The system under design is composed of the application interface and the database that's going to hold the records. Okay? So maybe these guys don't have a database in place already. They're just starting up. We're going to need to build a database for them too. The user is the primary actor. He or she is the one whose goal, get the information about the dog, is being met by the system. You might think the primary actor is the dog, since they're the one that's being serviced, but that's not the case. The primary actor here is the person that's going to actually be using the system. Okay? Now, in this particular case, it's actually kind of interesting because there's two primary actors. We're going to see as we get into a little bit more detail. Okay, when we look at this in a little bit more detail. But you're going to have a person who's going to be checking the dogs and checking them out. But then you got the groomers, okay, who are also going to be checking the system to see which dog is next, where they are. And those two actors actually are going to access the system and use it in different ways. And that would be something that would come out of the use case as well once you explored it. The hosting entities are not primary actors. They're supporting actors. This would be the system that's hosting the database or whatever. They'll provide a service to the system that we're looking at. Offstage actors, really none in this case. You're not going to be interacting with any other agencies or anything like that. Okay, so here's the dog drop-off, or I could have called it, you should have had a verb up here, drop-off dog or something like that. Usually give it some kind of a number so you can reference it. And this is just a brief description. Okay, I'm not going to do the fully dressed one here. This is the type of statement you might get. So you would talk to the people that are working in the business and ask them what's going on. And they would say, the customer arrived with a dog. Now, I've capitalized the nouns here so we can sort of use them later on when we try and identify the objects in the system. But this is the type of statement you would get. Customer arrives with a dog. The user accesses it if the dog's record is available. If not, that's not a good sentence there. The user accesses the record, the dog's record, if the dog's record is available. If not, the user creates a new record for the dog. The user creates a service order for the dog, including the time of delivery, services to be rendered, preferred time of pickup. The dog is then placed in the kennel to await service. And that basically would be the type of statement you would get. That's a brief use case. It's not the fully dressed one, but in this case, if you were designing the system, you could probably pull out enough information from there to start a basic domain model. Okay? That's the key objects that are going to be in this system. Here would be another use case. The groomer checks the system for the next available dog. The system presents a list of waiting service orders in preferred order of servicing, prioritized by preferred pickup time. The groomer selects a dog to groom, retrieves the dog from the kennel, updates the service order to indicate the dog is being serviced. The groomer completes the required services, updates the service order to indicate the service is completed, returns the dog to the kennel. That's a brief description. Now, in this case, the primary actor is the groomer. Okay? He's the one that's updating the system, and his main goal here is to keep the system updated as he's performing the service. In this case, the primary actor is not really identified. Oh, it's the user. The user, in this case, is the person that's sort of up front, the receptionist that's going to be using the system to create a record or update the record with the dog and enter it into the system, the tracking system. Two different primary actors, two different use cases here that you would need for this particular system. Here's another example. This is a data entry system. Okay, so this person is sitting at a desk and they're entering data into an application, very typical software application you may have to develop. We're designing a data entry system. The primary actor is the data entry worker who will enter information into a user interface to create and update records for the client. Okay? During requirements workshop, a typical data entry worker is interviewed and describes the following process. So you interview the worker, and this is what they tell you. I received the paper invoices with the checks attached to them. I enter the invoice number into the system, pull up the record of sale. Then I enter the payment information into the system, including the payer name and address, the check number, the date you received, the amount, checking account number, and the routing number. This is what this person does. They get these invoices, they got a check attached to them, they pull up the record, okay, and then they go through putting this information. Now, you might further expand on this and say, well, what if there's no record? Okay, well, then I have to do something else. I have to create a record, and that's an extension, that's an offshoot. But from this description, you can put together a use case, okay, for this particular system that you're designing. Here's a brief use case. The system displays a screen that allows the user to enter an invoice number, because we're pulling that out of what this person does, right? I enter the invoice number into the system and pull up the record of sale. So your screen allows the user to enter an invoice number. The system accesses the sales record and displays the current information in the record to the user, highlighting fields that are related to payment. The user types information into the fields, submits the updated record, the system updates the sales record. That's a brief description. That's a brief use case. Now, you could also expand upon this, like I said, what if there's no record, things like that. Those would be extensions. This would be a brief example of a brief use case for this system. Here's the fully dressed version. Enter payment data to sales record system. The scope is the sales record system. That's the system we're working on. Okay. This is a user level goal. The actors are the data entry worker, which is primary, the system is supporting. Stakeholders, data entry worker, enter payment information for invoice into the system. That's what this user is trying to do. Bank, properly track payments for sales. Preconditions, there is an active network connection between the data entry worker and the record, the sales record database. So they're working kind of, there's some type of a network connection between the application and the database. Assume the precondition. Okay, here's your main success flow. The use case begins when the user enters an invoice number into the search screen, and now you just go through the steps one by one in this use case. System retrieves the sales record and displays the information to the user. Boom, fills in the fields. System highlights the areas that are related to payment information. User types in the payment information into the fields indicated by the system. User submits the record to the system to be updated. Alternate flows, leave the details out. You would just sort of list these out in an invalid invoice number. User attempts to submit the record to system before all the payment fields are filled in. User enters invalid information. System fails to update the record. Those are the types of things that you could identify as alternate flows, and you would go on and create use cases for those. Okay, you see how this starts to branch out. Post-condition, success guarantee, successful completion. Sales record has been successfully updated in the sales database. That's how you know the use case completed successfully. Failure condition, the sales record has not been properly updated, and the payment information in the sales database. Special requirements, the system must contain a proper interface to an existing sales database. The payment fields are dictated by the database design and invoice design. Okay. Here's the main things that we need to take away from this first part, okay? First part of the lecture. Understand what the exception phase is. Brief introductory part of the process, right? The unified process. This is where the vision is defined, the main feasibility study. Understand the FRUPS model. Requirements classification. Know those different specifications and how to classify requirements. Understand how the use case model artifact interacts with other artifacts. Remember that diagram I put up, and the use case model artifact was in the beginning, and it interacts with the other artifacts. That's important. Be able to create a brief or casual use case. Know how to read through a fully dressed use case. Again, I'm not going to expect you to memorize the template in the book. Okay, but you should be able to read through those things. And what's coming up next, you're about to find out, because we're going to move right on now to the next set of presentations, okay? Okay, so here we go. Here's part 2. Use cases, more use cases. 2 whole lectures on use cases. Yes, they're that important, okay? This is where the fundamental behavioral requirements of a system, the functional requirements are defined in the use cases. So here's what we're going to learn now. More examples on how to define use cases, how to find them, how to construct them. We start looking at how UML applies to this, how to work with use cases and iterative methods, because these will iterate, and then how to relate use cases. So, just a quick review of what we talked about earlier. Use cases are text, not diagrams. We may construct diagrams later. We'll see how to do that in a couple minutes. These are created as stories. Functional requirements come from them. Actors, something that exhibits behavior in the system, not just a person. It could be another system, right? Scenario, specific sequence of actions and interactions between the actors in the system, okay, for a use case instance. One particular story of using the interface, using the system. That's a scenario, okay? So use case is usually one scenario. Use case, informal, collection of related success and failure scenarios to describe an actor using a system to achieve a goal. This was the formal description from rational unified process, okay, more formal definition. Set of use case instances or scenarios where each instance is a sequence of actions the system performs that yields an observable result of value to a particular actor. Do we need to memorize that for a test? No, don't memorize that for a test, okay? Just wanted to show you that there is a formal definition. Here's the diagram that I put up before. There's the use case model artifact. You see how it interacts with the design model artifact, the design model down here, the domain model up there, some other artifacts over here, the vision, the glossary, and the supplementary spec. This is the business modeling discipline. This is the requirements discipline. This is the design discipline, okay? You should be able to read that, take a look at that figure and understand it, okay? And understand what it means. So, how do you find use cases? It's one of the hardest but most important parts of the project. How do you do this? All understanding of requirements and hence system design are going to flow from here. This is really where the majority of the requirements are going to come from. It's critical to understanding the first step in system development. Interact closely with customer, client, user. Critical. Never develop a use case without talking to your customer. Never assume you know how the system's going to work. Okay? Guaranteed to fail. All right? You could say, I know what your system needs to do. Don't worry about it. I'm going to design you this great website. Where do you see this? Trust me, they will not be happy. Okay? We're not mind readers. We're developers. We have to understand what they want. They have to tell us. Interact closely with them. This is where agile development really helps. Customer means the person that is actually purchasing the software. Okay? That's what customer means. One great strategy, take an actor perspective role play. Okay? Have people in your team pretend they're members or pretend they're the actor, or bring in the actual people that are going to be using the system and interview them. Each use case should be designed to satisfy a goal or a primary actor. Always I try and identify the goal up front, what's being accomplished here in this use case. Now, it's good to know what the system boundaries are. This will often help you. Determine the edges of the system being designed. We kind of did this with the dog grooming example I just did a few minutes ago. Okay? What are the boundaries? Is it the software and the hardware? Does it include the person using the system? What's the boundary of what you're looking at here? We're determining the domain of the system, and we're going to get more into this when we do domain models, but you will do some of this analysis early on when you start with the use cases. And remember the sequence here. You do the inception phase, and usually in inception, you will do some use cases, but you do the use cases before you do anything else, because this is how you understand what the system's going to do. Then you'll develop a domain model, and then you'll develop a design model. Now, when you're doing iterative methods, you do all those three things kind of over and over again at the same time. So I don't want to give you the impression that it's use case, domain, design, because you're going to iterate. You're going to go back and revise the use cases and add more, and then you're going to revise your domain model, and then you're going to revise your design model, and you're going to keep going back and forth on that. But there is sort of a basic set of a basic sequence here. You always start with the use cases first because they're the story of the system. You really can't do a design model without use cases, okay? Think about our point of sale case study. What's the system boundary here? In this case, the system under design is the software and the hardware associated. So for this particular case study, right, this is the checkout, the checkout in the supermarket. We're probably going to deploy not just the software, but also, the scanners and stuff that go with it. Now, from our purposes for this class, we're just designing the software, okay? But this will help us to figure out what the system boundary is, and that'll help you determine who the main characters are, who the main actors are. Cashier, store databases, payment authorization services, all that stuff's outside the boundary of the system we're working on. So what are we deploying? We're deploying this system that people are going to use to check out at a grocery store or at some kind of a supermarket or some store. What's outside the system? The cashier, any databases for inventory, payment authorization for credit cards, all that stuff is outside the boundaries, okay? So that can help us identify some of the actors. The people that are outside the boundary of the system are the people that are going to be using the system. Or I shouldn't say people, the things that are outside the boundary of the system are the things that are going to be using the system. Might be a person, might be another system, might be a payment authorization system that might be interacting with your system. Those will help you identify the actors. Doesn't mean that they're not important, they're just simply outside the boundary. If you're having trouble identifying the boundary, identify the external actors, and that should help define it, okay? Actors and goals are usually defined together, because in order to identify the primary actor, you usually must know what the goal is. So early on in use case development, you start identifying the actors that are going to use the system and what their goal is, okay? And this is kind of important. You don't want to jump right in and start figuring out how people are going to use the system right away. You start off saying, okay, who's going to use it and what are they trying to do? Okay? Remember, what and then how. So I'm a customer using an ATM machine. What do I want to accomplish? I want to get my cash out. Okay, start with that. All right? Then you can start figuring out how the machine's going to do that, and that will eventually lead you to the design. But you always start with the actor and the goal. What's the goal? What? What is the person trying to accomplish? Do the what first, the how comes later. Ask the fundamental question, how is the system being used and by whom? Okay, so that's a how, but what I'm really asking here is, what is the goal that's trying to be accomplished here? What is it that the system is going to do to help this actor achieve that goal? What is the actor trying to accomplish? Who starts the action? Who provides what? Who monitors what? That gives you the idea of who the actors are. Actors can be other systems, like a payment system or a database, not necessarily human users. So actor here doesn't necessarily mean human. Usually done in the requirements workshop, brainstorm sessions right up front, early on. You do these things early on when you start discovering the system. One useful approach, create a table. List all the actors and their goals and identify the primaries. So this is an actor goal table. You'll just create a table. Real simple, one column for actors, one column for goals. You identify the actors, you identify their goals. Primary actor is the one that has a need or goal fulfilled by the system. Supporting actors, they'll provide a service. So the primary actor is having their goal met by the system. Secondary supporting actors provide a service to the system. Offstage actors, they have some interest in the behavior, but they're not primary or supporting. Primary actor may be defined based on the choice of the system boundary, as I said. Draw the boundaries of the system, you'll see the actors. Okay, so in use case modeling, we ask who uses the system and how, rather than what does the system do, okay? So you're trying to figure out how does this person use the system, what goals do they have, and once you identify the goals, then how does the system address those goals, okay? Now, aren't we doing the analysis what part here? Yes, but before we get to that, we need to understand the system from the actor's perspective. So you look at this from the actor's perspective first, okay? What are they trying to accomplish and how does the system meet that goal? Don't do the design up front. Best approach to this is to identify the actors and then ask, what are your goals? Are they measurable? Gets to the heart of what stakeholders really want out of the system. Also helps to avoid slipping into design too early. If we concentrate on the end goals, everyone stays open to new solutions to meet those goals. Here's a picture of the point of sale system. So you've got your system, here's your checkout service, there's the cashier. Main goal, process sales. That's what that person's trying to do, okay? If you were looking at the overall system as being the enterprise of selling things, okay, then the sales system would probably be a primary actor here because their goal, what are they trying to do? Analyze sales and performance data and track sales. They would be the primary actor. If we were designing a system that was not just processing the sales, but also doing the tracking of the sales and also analysis of the sales data, then this would be the primary actor. Because you see the system is now, the system boundary is now larger than just the actual checkout service. Okay? But if we're just going to look at the checkout service, this really becomes a secondary actor. They're not the primary actor here. The system is really just designed to provide a checkout and process the payment for the sale, in which case the cashier is the main one, the main actor that's going to have their goals satisfied by the system. Okay? So this is why I say it's really important to identify what the boundary of the system is. What exactly is it we're designing? And this would come out very early in the inception phase. The company would either tell you, we just want a system that checks things out and we already have an inventory system that you're going to interface to, or we need everything. We need a checkout system and we also need a tracking system and we want to be able to analyze the data, in which case it's a much bigger project and you're going to have to add more things and have a new primary actor. Okay? And then if you're outside this thing, then you start looking at the customer, their goals to buy items, and the sales tax agency, well, their goal is to collect taxes. These are probably going to be secondary to this, or off-stage actors, if you're just talking about this. You really don't, I probably would consider them supporting if you're doing this, because they're going to provide a service. They may do the tax calculation for you. But whether or not you classify these as supporting or off-stage isn't really that important. The main thing is identifying the actors and their goals. What is it that they're trying to accomplish? Okay? Once you do that, you can start figuring out how the system is going to do it. How is the system going to provide those things? And we'll get into that later on when we start looking at the domain model. Primary actor. Previous diagram implies the cashier is the primary actor for this point of sale case study. For the store checkout system, the cashier is going to be the primary actor. What about the customer? Customer's an actor, but not primary, because their need is not really being met by the system, okay? Their main goal is just to purchase things and get out, okay? They don't care whether the cashier takes the money or whatever. They just want to pay and get out and move on. So their goal is not really being met by the system. The system is being designed to meet the cashier's goal. Look at the system boundary. For this case study, the system is a point-of-sale system. Unless it's self-checkout, then the customer goal is not the principal goal here. Now, if you're doing a self-checkout system, yeah, then the customer becomes the primary user, the primary actor, because they're the one that's going to interface with the system, right? In this case that we're looking at, it's going to be the cashier. They're the one that's going to basically be interacting with the system. The cashier's goal, look up prices, get the total, process payment, is the main goal to be fulfilled by the system. The system is being designed for use by the cashier to meet his or her primary goal. This goes back to the basic definition, the basic domain definition. What are we designing? And again, like I said, if you draw the boundaries and you figure it out, you'll be able to find these primary actors. If the system under design is an entire sales enterprise system, as I said before, then the customer could be the primary actor. If you go back to the outer box on the previous slide, then the customer becomes the primary actor because they're the one that's going to really be interacting with the overall system. So let's put all this together. First, define the system boundary. Defining the limits of what the services the system are going to provide. This comes out of the inception phase. What is it that this thing is going to do? What are the boundaries? Are we just doing the software and the hardware for point of sale checkout? Are we including all the tracking? Or are we looking at the entire experience, in which case the customer is going to be the primary actor? You define the actors and their goals, including the primaries. Once you know the boundaries of the system, you can start figuring these guys out. Role play. Create actor goal tables that'll help you identify the main goals that these guys have. Okay? You can also do this by analyzing the events that may take place and then identifying the actor generating the event and the goal of the actor. This is all stuff you pick up through experience, working through it. How is the system going to be used? Finally, define the use case. Generally, do one use case for each user goal. Don't make them too complicated. Use a name that describes the goal, start with a verb. Okay? Check-in dog. You get money from ATM machine. You usually start with a verb that describes the goal, what's trying to be accomplished here. Often, these CRUD goals create, replace, update, and delete. You know what CRUD means? That usually refers to database operations. These are usually collapsed into one goal called manage X, where X is whatever's being managed. So you don't usually do a separate use case for create an account, replace an account, update account, delete an account. You would put all that into one thing called manage and just sort of leave that. Because these operations are so standardized that it would basically be understood when you get into the development phase. And it's essentially going to be the same operation, just whether or not you're creating, reading, updating, or deleting. Those are standard database type operations. So at this level, you don't need to do a separate use case for each one. You could do one use case, just call it manage user accounts, and it will be understood. Okay, so how big or how small? Well, it really depends upon the context. How big do you want to make a use case, or how small? Generally, the use case should define tasks performed by one actor in one place at one time in response to an event. Okay? You don't want it to be too complicated. You want it to be fairly straightforward so that you can analyze it and pull the functional requirements out. If the use case is growing to many pages in length, then consider cutting it down. Okay, if you get like a 5 or 6 page use case, too detailed, all right? Especially for a brief use case, it should just be one paragraph, all right? And a lot of times you're happy if you get that. If you get a paragraph description of something out of a customer, that's good. Sometimes you get like 1 or 2 sentences, okay? Detailed, fully dressed, more details, but you don't want this to be 5, 10 pages long, okay? It shouldn't be that detailed. If the use case is only 1 sentence or step, probably too small, it's probably not even worth exploring. You got like a 2-sentence use case, it's like, okay, do we really need to document this? I mean, it's pretty obvious this will come out later on. Is there a basic business value in the use case, all right? What's important here? You want to capture the critical things and the things that are very important. Which actors are impacted and how? This is how you would read through this. What are the impact of the overall business? For the point of sale case study, there's a big difference between credit card rejected and Visa or MasterCard. Okay? So this would be a use case if the credit card is rejected. Right? If you're doing a point of sale use case, this would probably be an offset. You do an extension to a separate use case. Okay, what happens if the person checks out and the credit card's rejected? You probably wouldn't do separate use cases for Visa and MasterCard checkout. Because as far as you're concerned, it really doesn't matter. It's going to be a different agency you're going to interact with. Yes, when we get down to the lower details of the code, we're going to have to know how to interact with these different agencies, and we'll see more about how to deal with that later when we get into the design patterns. But at this stage of the game, this is probably not worth creating 2 different use cases for. It's just a particular type of credit card. Don't worry about it. Okay? This, on the other hand, yeah, that's fairly significant. Now, how do you know this? Yeah, I guess it comes about through experience. After a while, you'll realize, okay, these use cases are too similar. We don't need them. You can combine them. Okay? And a lot of this comes about through an iterative process as well. When you're doing an iterative development, you may start realizing these use cases are really kind of similar. Let's just combine them into one. We don't need 3 different use cases here. Or you may be working on a use case and say, this is way too complicated. We've got to break this up into separate use cases. You just have to be flexible, and you'll figure it out as you go along, but it does take some experience. Okay, back to the dog grooming business. Here's your picture, right? There's your receptionist. You got a couple of groomers here and there. There's your kennels where you're going to put the dogs, right? That's what the business looks like. You walk in, you take a look around. You want to identify the primary actors here. Who's using the system? Well, as I said before, this person, right? So people come in, they drop their dogs off. This person's going to access the system. What does this person need to do? This person needs to be able to pull up a record, and if there is no record for this particular customer, create one. So there's a primary actor right there. These guys are also going to be primary actors, but in a different use case, because they're going to be checking when they finish a dog. They're going to go check the system and see, okay, who's next, and then go get the dog and bring them and service them and put them back. So what we have here for this system is we basically have 2 different primary actors using the system in 2 different ways, okay? This would come about when you talk to the customer, you maybe do a site visit, you try to figure out exactly what's going on, and you start understanding how the system's going to work. Okay, dog grooming. Who are the primary actors? Well, the receptionists, but also the groomers, right? And we figured that out by taking a look at the system and seeing where the boundaries were, right? These are the main boundaries. There are 2 main users of the system, and here are their goals. Receptionists, they want to track the dogs. Okay, so an owner knows they're ready. You check them in, you check them out. If you get a phone call from an owner going, You know, is Fido ready? Yeah, this person wants to be able to look it up. Yes, you're ready to pick up your dog, or no, they're being processed, or that's that person's goal. Because they're going to get phone calls, and if you were to interview this person during a requirements workshop, that person would say, I sit at the front desk, people drop off dogs, I check them in, people come pick up their dogs, I check them out, and then all day long I get phone calls from people wanting to know whether they can drop their dog off or if their dog is done yet. That's the type of information you would get from that person. Okay? What about the groomer? What do I do? Well, I take the dog, I put him up on a table, I cut his hair, I paint his fingernails, I do whatever is supposed to be done, and then I put the dog back, and the system's got to tell me which dog to do next, right? Because I need to know, there's got to be a prioritization system there someplace. I need somebody to tell me which dog am I supposed to do next, because I've got, 10 cages and all these dogs lined up. Somebody's got to tell me which dog is next. So that's his goal, right? Which dog I'm supposed to service next, and he grooms the dog and he puts the dog back, okay? Each of these actors uses the system differently, and they're going to generate a different use case. And that would come out of the requirements workshops. You got a use case for checking in, checking status, checking out, and payment. That would be the receptionist. You got a use case for finding the next dog in the queue and identifying the service, updating the service order, that's the groomer, and probably when he finishes servicing, updating the system to say, yeah, the dog is ready to be picked up now. So you see what's come out of this. You talk to these people, you figure out what their job is, and then you start figuring out where to go from there. Okay? Primary actors, goals. Look at the system, look at the boundary, figure out what they're supposed to do. The only real way you can do that is by interacting with the customer, right? I mean, you don't want to just sit there and say, okay, I think I kind of know how this guy's company's going to run. You never develop use cases without talking to the people who use the system, okay? We were doing the wireless standards. Customers were the operators, AT&T, Sprint, Verizon. They were the ones giving us the requirements. This is what we want the system to do. And then we went off and wrote the standards based on those use cases. They actually wrote use case documents for us. Now, you can apply some UML to use case diagrams, okay? I don't think it's particularly useful, but it can be in certain situations. Note that the diagrams are secondary in use case development. Everything we've talked about this morning is in text. It's all text. They're stories. They're written. Okay, they're paragraphs. And it is often used just as an easy documentation tool. Remember, use cases are carefully crafted text. You can create some diagrams here to more or less document the use cases so you can keep track of them. That's how you can use UML to do a use case tool, a use case diagram. It's good to use these when you're working out the actors and the goals and the actor goal list. You can create a diagram that may help you identify actors and goals. It can also be very helpful in deciding the system boundaries, to decide what's inside and what's outside. But use case diagrams are tools. They should only be used to understand the system and use cases under development. Never accept a use case diagram as the official use case model for a project. Okay, why? Because it has no information in it about the use case itself, as we'll see in a minute. Use case diagrams tell you nothing about the actual details of the use case. You can't get any functional requirements out of them. Well, I mean, you can, but you're making them up yourself, okay? You'll see in a second what these things look like. There's very little information there as to what the use case actually is. So some people want to give you a diagram. This is how it's going to work that out. You get it in writing. Get it in writing. These diagrams are too vague, and you're leaving yourself open to misunderstanding later down the road, okay? If somebody gives you a diagram and says, this is what I want the system to do, you're probably going to have a miscommunication, and you're probably not going to give them what they want. Get it in writing, okay? I want to sit down with your users, and I want to write out specifically what they're doing so I understand how the system's going to be used. This is an example of what a use case UML diagram would look like. It's kind of hard to read, but in here you sort of have some various goals. Process a sale, handle a return, cash in, analyze some activity, manage security, manage a user. And here you have some actors. You got a customer out here, you got a cashier, you got a manager. The cashier's goal is to process the sale, but also handle the payment and also cash in, okay? Over here you got some supporting actors like a payment authorization service. And the payment authorization service has an interest in the processing sale. You may have a tax calculator out here, that's an actor. They would have some interest in processing the sale. You may have an accounting system or an HR system. They may be interested in when the cashier cashes in. Over here, you may have some kind of a sales activity system that tracks the sales. They may just, their goal is to sort of analyze the activity. And you got some kind of a system administrator that'll be managing security and things like that. So typically, this is what a UML diagram would look like for a use case, right? It basically helps you identify the goals and the actors and sort of shows you which actors are involved in which goals. But you can see from there, compared to the use cases that we've been looking at before with all the text, you can't tell me anything here about this use case, right? The customer is primarily interested, or the cashier is primarily interested in processing a sale, but this tells me nothing about how that happens. So if you were to try to design a system from something like this, you could come up with anything, okay? There's not enough information here to pull requirements out. I'm not a real big one on using diagrams for use cases. I mean, sometimes they can be useful if you're trying to understand, something specific in the system, but in general, something like this is okay. You probably could take the place of a actor goal table if you want to see it as a diagram, but I'm not big on that. This is a little bit more detail as to how it would actually work. For a use case context diagram, limit the use cases to user level goals. So you sort of put them in here. Your primary actors are usually on the left. Your supporting actors are usually on the right. Okay? Computer system actors, right over here, you see like the payment authorization service would have an interest in this particular goal. That's one way you could diagram a use case. There's other ways of doing it. Sometimes you'll see actors drawing these little stick figures, or sometimes you'll see a little, you'll see something here that says system that lets you know that that's not actually a human, it's a system. Do a little keyword there. Or you could have a little stick figure and a little box next to it that says this is an actor, payment authorization. These are just some alternatives of how the UML can be used. Class box style can be used for any actor, computer, or human. I don't know, I mean, that's just different ways you can notate it. Okay, and sometimes you'll see these diagrams used for use cases as well, the little stick figures with the box diagram. Here's some observations. Don't design. Don't suggest coding. Real hard for us engineers type guys, right? Because what's our instinct is to find a solution. That's what we do. We find solutions to problems. The use case development is the identification of the problem. The first thing we want to do is jump right in and go, oh, you know a really cool way to do this would be? If we set the database this way, we got a relational database, and we can really stuff this really cool interface so you can, don't design. This whole thing is just figuring out what the system is doing. We're not doing the how part yet. We are trying to understand how the system is going to behave, but we're not designing the system yet, okay? Don't do that. UML can also be used to create activity diagrams, which are workflow diagrams. We're going to take a look at some of those later on. Like I said before, sometimes you may have some diagramming here, which will sort of describe how work flows through. That's okay to help you understand the process. But again, the use case really should be a text. It should be something written that you can refer to. Avoid detailed function lists. This is kind of old school, tedious, and not efficient. Write user stories. So you don't want to sit there and say, these are the functions that the system is going to do. Okay, a function list. That's kind of old school thinking. Write the user stories, use cases. That's usually a lot more effective. Use case model artifact captures the functional requirements. That's what the use case model artifact does. And the use case model artifact is a collection of these text stories, possibly the diagram that I just showed you before, and then a couple of other things that we're going to get into later on, showing system events and basically how those are handled, and sometimes operations contracts. We'll talk a little bit about those in a couple of weeks. Okay? So the use case model artifact is sort of a collection of things. If you go back to that diagram I put up earlier this morning and showed that thing in the middle, it's a collection of things. It's an artifact. Okay? Remember, there are other UP artifacts that may still collect requirements, non-functional requirements, domain rules, and they can be captured in the supplementary specification. So there are other things out there that can catch requirements, okay? What the use cases are good at is capturing the functional requirements. What is it that the system's going to do? How is it going to behave? The vision document artifact may contain a list of high-level system functions as these are necessary to define the scope, but avoid, again, the whole function list thing. That's kind of old-fashioned. Let's take a look at this Monopoly game for a second. You remember the Monopoly game? This was one of the case studies. This was the other case study we're going to look at. This was going to be a simulation of Monopoly. Okay? Now, in this case, the use case turns out to be pretty simple. But this was a software version of Monopoly. It's going to be a simulation of a Monopoly game. This will run as a simulation. I just realized I'm standing in front of you. I'm sorry. Have I been doing that all morning? I've got to find a place where I can stand. I've been standing right in front of you all morning. Oh, man. Okay. I'll stand back here. I can stand in front of you guys.
Yeah.
Sorry about that. Just standing in front of that guy all morning. Okay. Software version of Monopoly game. This will run as a simulation. The user will configure the game, the number of players, start the simulation, and let the game run to its conclusion. Computer simulation. That's the scope. That's the vision. That's the big picture. It's not a use case. It's just sort of a description of what this thing is. Trace log is going to be created to record each move the player makes. This would be something you'd get out of the inception phase. What is it we're trying to do? Here's the use case. So this is an example of a project where most of the requirements are not captured in the use case. Okay? Because in this case, it's going to turn out that the functional requirements of this particular system are very, very simple. The system's going to do one simple thing. There's other requirements it's going to have to meet, but the functional requirements, the way the system behaves, are actually pretty simple. Okay? In this case, there's only one simple use case, and there's one primary actor. The player starts the game, the simulation. The player, whoever's playing this game, is the primary actor. That's basically it, right? That's it. That's the use case. The player starts the game and observes the results. That's all there is to it. So does that mean there's no requirements? No. The functional requirements are simple, basically captured in the project description on the last slide. But there are going to be other requirements. The game has to follow the Monopoly rules, okay? And those have to be captured someplace else in some other artifact. So this Monopoly game, the use case is really very simple. And you could come across systems that do this, right? I mean, you may have a system that just does a computation, right? The user just runs this system and does a computation. Use case is really simple. I put in the data, I hit go, it returns the results, okay? Not a whole lot of functionality there in the system, okay? A lot of other requirements in terms of the rules you use to do the computation, how accurate it is, and things like that. But from a functional perspective, not a lot in this use case. The system will have many rules requirements, the rules of the Monopoly game, but its behavior is pretty simple. Run the simulation. When it comes to like things like this, these rules or requirements, or rules requirements, things like that, these requirements are like business logic requirements, and they would be captured in the supplementary specification. We'll talk a little bit more about the supplementary spec later on, but sometimes you have certain business rules you have to follow, okay? For the Monopoly example, there would be the rules of the Monopoly game. They would be captured in the specification. They wouldn't be captured in the use case. You wouldn't say the player starts the simulation, the dice is rolled, this happens, that happens. If a person lands on this square, that happens. That's all captured in the rules of Monopoly, okay? And that's all internal to the system and how it's running. The behavior of the system to the user, remember, who's the primary actor here? It's the guy who's running the simulation, right? He wants the simulation to follow the Monopoly rules, but he doesn't interact with that directly. From the primary user's perspective, he's going to kick off the simulation and see the results. That's it. That's his interaction with the system. So as far as he's concerned, how does the behavior of the system, or how does the system behave? It runs the simulation, it prints out the results. That's all he's seeing. Yes, there are requirements that you have to follow the rules of Monopoly. They would be captured somewhere else in the supplementary spec. Okay? Okay. Here's a use case diagram, and it's pretty simple. There's your observer or your user. He's your primary. And what's his main goal? Play the Monopoly game. That's it. One simple use case, not much to it here. Well, if you really want to write it out, here you go. Use case UC1, play Monopoly game. Scope, Monopoly. I can't believe we actually did a fully dressed version of this, but we did. Primary actor, observer, stakeholder, observer, wants to easily observe the output of the game simulation. Main case scenario, observer requests new game initialization, enters number of players. Observer starts to play. System displays game trace for next players. See domain rules and game trace and glossary. So we got to have some kind of an indication for what the game trace is. Okay. Repeat step 3 until a winner is decided or the observer cancels the simulation. That's it. There you go. 4 steps. Okay. The rest of it, extensions. At any time the system can fail. The system fails. Support recovery system logs. Blah 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 blah. Now, we'll get into this a little bit more next time, how to extend use cases. But you see what's happened here. If I go back to the previous slide, I have these 4 steps that are under the main case scenario. When I come to the section on extensions, I have this little star A. What that basically means is this can branch off at any step in the main success scenario. At any time, I could go to like a 3A. The star, think of as a wild card, right? Wild card symbol. So this could happen at any step. It could be 1A, 2A, 3A, or 4A, and at any time, the system could fail. And if that happens, you got to support some kind of recovery system logs that are completed after each move. You would fill in some more details there as to what to do with system recovery. So the observer can restart the system. If it fails, the system detects the prior failure, reconstructs the state, and prompts to continue. The observer chooses to continue or not. Last completed player turn. So basically, if you were creating a log of all the moves, the system could just read the log, recreate the state of the game, and pick up from there if for some reason the system failed. Okay? This is an extension, and we'll show how to do this later on. But in general, this could happen at any point. And in this particular case, what the customer wants is if the system fails for whatever reason, the system can be restarted by the guy who's running the simulation, and it'll pick up where it was before by just reading the trace log and recreating the state. Okay? Provide both graphical and trace and text trace modes. That's just a special requirement that this particular user, this particular customer wants. Okay? Okay. So let's talk a little bit about use cases and iterative methods. UP is use case driven development. Very, very important. Use cases drive the behavioral requirements of the system. Functional requirements are primarily captured in the use cases, as I've said before. This means that you would not expect to find functional requirements elsewhere. In other words, if you're working on a UP project, the functional requirements are in the use cases. They are not anyplace else. That's important because if somebody comes to you and says, well, we wanted the system to do this, and you go through the use cases and you say it's not captured anywhere in here, then it's not a requirement. If it's a functional requirement and it's not in the use case model, it's not part of your system, okay? Critical to planning the iterations. Basically, the way you would plan an iteration, you take a look at working on a particular use case or enhancing existing use case. And this is why you're constantly working with the customer as you're iterating, right? You go through, you work with the customer, and you enhance a use case, and you say, okay, we're going to do this in the next iteration. Or you add a new use case, right? Okay, so maybe you develop for the ATM machine the login part, and that's all you did. Now I'm going to add in a use case for actually withdrawing money. That's going to be my next iteration. In UP, the main goal for each team is to design objects which, when collaborating together, will realize a use case. It's true of agile methods in general. You will hear this terminology. Realizing a use case. What that means is when you create your use case, you got the story for how you want the system to behave. You are then going to create the software that will realize that story. It will make it real. It will actually make the story happen so that a user can then use your software. By the time you finish designing your system, somebody should be able to sit down and make one of those use case stories actually happen. That's the goal. Okay? That's what you're trying to do. Use cases often give valuable material for the creation of user manuals, right? People want documentation on how to use the system. Use cases are great sources for that because they tell you exactly how someone's going to use the system. So very often you'll go through a use case. This is where the fully dressed ones come in, where you have all those steps. Very often you can just cut and paste right out of there into your user manual. Do this, do this, do this, do this. This is how the system works. Use cases also provide valuable ideas for testing. You got to write test case for your system, right? What do you expect? When you write a test case, you you always start off, you're going to do test-driven development, which we'll talk about later. You start off with the expected result. What do I expect the system to do? This is what I expect to have happen, and then you develop the objects or the code to do that. That's test-driven development. We'll see that later on in the course. But you can go to the use cases to pull that out, because the use case tells you how the system's supposed to behave. So use cases are very useful for testing, for writing test suites, because you can go through here and pull out the behavior of the system and say, for this test, the system should do this. Okay? Often development requirements workshops held with the customers. Yes, we already know that. What about these requirements workshops I've been talking about? Usually attended by a system analyst, a developer, a software architect, customer, end user, etc. These are workshops where the customers, the business end, and the developers get together. They're held throughout the inception and elaboration phases primarily. Once you start getting to construction, by that point, 90% of the requirements are nailed down. You'll still interact with the customer, but it's more or less just touch base to make sure they're getting what they want. During inception, you're going to start by identifying the stakeholders and the goals. You'll create the actor goal table mentioned earlier. Who are the main primary actors here? What are the main goals that those actors have? Then you create a list of use cases by name only. Maybe write a few brief descriptions for a few of the most critical ones. So what you would do is you would identify the actors and the goals, and then you would write the names of some use cases. Pick-up dog, check-in dog, drop-off dog, okay? Don't fill them out yet, just identify those main actions. And then on a few of the critical ones, like I want to be able, the real critical to my business, if somebody calls and wants to know where, whether their dog is done or not, that's a critical one. That would be a high priority use case. That's a high risk use case. You would identify those guys, a few key use cases. Those are high risk. They have to work, and those are part of your core architecture. And those you might actually write out in fully dressed form early on, okay? During inception. During the inception phase, you may actually do a couple of these guys. You may do a deep dive into a couple of these ones and identify it, because these are the ones you're going to hit the ground with first in elaboration. Now remember, with iterative development, you're writing code all along. Very first iteration, you're going to start writing code, okay? So you've got to identify the key use cases, and you've got to do some deep dives here to figure out what you're going to be doing. So I don't want to give you the impression that inception is just, a bunch of guys in suits sitting around drinking coffee, making big decisions and saying, yes, let's do this. There is some detailed work here that can be done. Identify a high-risk use case and do a deep dive and make sure you know what you want to have done, because the first iteration you're going to start coding, okay? You're going to start coding right off the bat. Then during the elaboration phase, you'll meet at regular times during each iteration, refine the existing fully dressed use cases based on feedback and go from there. Create more fully dressed versions of the other use cases, maybe add some ones from there, and you keep going. Okay, some details on iterative development. How are we doing? You guys tired yet? I'm going to sit up here blabbing for like almost 2.5 hours. You guys aren't, you're very quiet. You're not saying anything. You doing okay? Is this all right? Yeah. Nobody's fallen asleep yet. That's good. You have any questions? Comments? What's that guy talking about up there all day? Okay, we're almost done. We got a few more slides, and I'll let you guys go. Very good. You guys are good. You sit there for 2 hours and a half. I don't think I could sit there and listen to myself for 2.5 hours. Okay. How does this relate? In UP, each artifact is owned by a discipline. Remember the main disciplines we were talking about, right? There was business modeling, there were the requirements, the design, and there's artifacts, right? The design model, the use case model, the domain model. These are the artifacts, and they're each owned by a specific discipline. The requirements discipline owns the use case model artifact. Okay, now this might be a group of people, it might be a particular team, it might be a particular project in a company. The requirements discipline owns the use case artifact. Artifacts are developed over the course of the phases of the project. Okay? Inception, elaboration, construction, and transition. So the way it works in iteration and iterative methods, you don't say, okay, use case model is done here and then we're done. Right? These things are developed and they're modified throughout the course of the entire project. That's the whole idea behind agile methodology, right? Flexible. Nothing is ever really shut off and done. You're constantly revising. Some artifacts are started later than others. Some may be revised in multiple phases. And we'll learn more about this as we start getting more into agile methods, but this is common in agile. You don't freeze the requirements. You never really freeze these things until you're finally done. In this particular case, the use case model, which we've been talking about this morning, it's owned by requirements. During inception, you'll hold initial requirements workshop to identify high-level use cases, brief descriptions, maybe 10% of the high risk and architecturally important, and do a deep dive and define some of those in inception. During the iterations of the elaboration phase, hold requirements workshops near the end of each iteration to expand on the use cases based on feedback received from the developed code, add details to the higher level use cases. By the end of elaboration, 80 to 90% of the use cases should be cleared, written in detail. The rest are fleshed out during construction. This little picture here kind of shows you a little bit of detail as to some of the artifacts and when they're started. So here's your disciplines right here: business modeling, requirements, and design. Right. Here's an artifact, and here's your phases. Inceptions, that short phase in the beginning. Elaboration, which is probably 4 or 5 iterations. Construction, which is the majority of your iterations, and then transition, which is sort of the end where you deploy. Now, in business modeling, you have what's called the domain model. That's usually started and refined during elaboration. Okay, and we haven't talked about domain modeling yet. We're going to spend a lot of time on that. I think we may start on it next week or the week after is when we'll start getting into domain models. Requirements, this is the use case model we've been talking about. Started in inception, really refined during elaboration. It can actually be refined out here during construction as well, but the majority of it's done here. You never really freeze it, but the majority of it's done here. The vision document is started in inception, could be refined during elaboration, but it's mainly done in inception. Supplementary specification and glossary started here, refined more out there. Now, you never really do design during inception, okay? Design is the how is the system going to work, how is the system going to meet these goals. You start off doing the requirements first, and then you will start doing some design here, and then you'll refine it more during construction, okay? But you see, there's never really a start, finish here. It's iterative, as I'm sure you guys are probably picking up on by now. The design model is done here. There's also a software architecture document, which we'll talk a little bit more about later on. This doesn't necessarily have to be a paper document, by the way. It could be something else. But these guys are usually not started to elaboration. They will get refined more during construction. Okay? Okay. Main takeaways from Chapter 6. We have finished use cases. Understand how to create use cases by defining system boundaries. Identify the actors and the goal. Who's using the system? What are they trying to get out of it? Understand when and how use cases are created throughout the iterative process. Okay? They are going to be iterated. You start in inception. You work them out during elaboration. Okay? Be familiar with how to read and write a brief use case. You should be able to read a fully dressed use case. Again, I don't expect you to memorize the template. That's kind of worthless. But make sure you understand with this unified process, the phases, the disciplines, the artifacts, when these things are being done when. That's kind of important, I think. Here's what's coming up next. We're going to have our first quiz next Friday. It'll be in the first part of the class, maybe 20 minutes or something. I don't know, maybe 10 or 15 multiple choice questions. Just make sure you're paying attention. We're going to talk about how to relate use cases. This is Chapter 30. Now, like I said before last time, we're going to jump around a little. This is the way he developed the book. He comes back to use cases later in the book, and he expands on them. But we're going to go ahead and we're going to study that now, because you guys need to see everything up front. So, Chapter 30 talks about how to relate use cases to each other. We'll look at that next Friday after the quiz. We'll talk about other requirements and how to find them. That's in Chapter 7. Talk a little bit more about the system specification document there and some of the other artifacts that capture other requirements. And then we're going to start talking about the first iterations, and we will introduce domain models next Friday as well. And that's Chapters 8 and 9. So if you want to read ahead, Chapter 30, 7, 8, and 9 for next Friday. I am posting the slides up before the lectures now. I think you guys may have seen that. So I'll have these slides available. I'll probably post them up on Thursday. Assignment 1 is due Wednesday. Write an executive briefing on different types of agile methods. And then probably another week or so after assignment one is turned in, we'll start the project. I'll give you an overview of what the project is next Friday. I'll give you a description of that, and then your first part of the project is going to be to write a use case, at least one, maybe 2 or 3 for the project, okay? So the project's going to be 4 parts. We're going to do the use case, the domain model, the design model, and then coding. We're going to take you through an entire iteration of working on that project, okay? Is that enough information for one day? That'll keep you going for a week, right? Does anybody have any questions? You never do, but feel free at any time to interrupt me, during these lectures. Just raise your hand and go, wait a second. If I'm going too fast, just ask me to slow down. I won't, but you can ask anyway. And have a good weekend, guys. Okay, if you have any questions, reach me by email. Get your first assignments done, turn them in. I will see you next Friday.